The critical path method is one of the most common methods to define the duration of a project. It is the so-called one-point technique. Why one point? Because we work only with a possible duration for each activity. We will later see that there are other techniques that use more than one possible durations for each activity. That's the reason why we call the critical path method a one-point technique, because we work only with one possible duration of each activity in the project. The starting point of the critical path method is to prepare a table like this with all your activities listed here in the first column. Then the dependencies. What we mean by the dependencies? By the dependencies we mean what is the activity that can only start once a previous activity has been completed. For instance, here, activities B and C can only start once activity A is completed. Activity D can only start once activity B is completed. So the first step is to define the dependencies. The next step is to define the duration of the different activities. Activity A will have a duration of 3 days, activity B will have a duration of 4 days, activity C a duration of 2 days. Once you have established the dependencies and durations, the next step is to present in a graphic format the dependencies between the different activities. And you prepare a diagram like this, where you see the dependent activities and the relations between them. Once you have that, you can move for the next step of the method. In the next step of the method, you will establish the linear sequence on the basis of the early start and early finish dates of the different activities. How does it work? You have these 6 different boxes where you have the name letter of the activity, activity A, for instance. The day activity A starts is the first activity in your project, so it starts on day 0, project starts on day 0. Then the duration of the activity, we know from the previous exercise that activity A will have a duration of 3 days, so it means that the early finish date of activity A is day 3. It will start on day 0 of the project, will have a duration of 3 days, and will be completed by day 3. This is the early finish date, and you apply the exact same calculations for all your activities according to their dependencies. And you have what we call the linear sequence. So you see here that activity A will be completed on day 3. So it means that activity B can actually start on day 3 because it depends on activity A. Activity C, the same thing. They depend both on activity A. They can start on the day 3 of the project implementation. Activity B starts on day 3. It will have a duration of 4 days. It will be completed. The early finish date will be on day 7. Activity C will have a duration of 2 days, which means that it can be finished on the 5th day of project implementation. So on and so forth. But then when you arrive at activity G, you see that activity G has 2 antecessors, D and E. When you are establishing the linear sequence, of course you will consider the latest date. Why? Because activity G can only start once both D and E are completed. Maybe we can finish activity E on day 6, but we can only start activity G once D is completed, and D will only be completed on day 12. So 12 goes there, of course. 12 plus 4, it means that activity G will be completed on day 16. Activity H, we have exactly the same problem, because F will be completed early on day 7, but we still have to wait for the completion of activity G on day 16. So it means that activity H can only start on the 16th day of project implementation. 16 plus 3 days of duration of activity H means that the project will be completed on day 19. We have established the linear sequence. We have defined how much time we need to actually implement our project. We will need 19 days. The linear sequence has been established, and this is a very important part milestone of the technique. We know how much time we need to implement the project because we analyze the sequences and dependencies of the different activities and the duration of them. But we are not over with the method, because then we will look at the regressive sequence, late start and late finish date. What we mean by this? We'll complete our 6 boxes here. We know that activity B will be completed on day 7. We know that already from the linear sequence. So 7 goes here to the lower right corner. 7 minus 4 days, it means that we can start activity B on day 3. That is the latest date to possibly start activity B. It will be on day 3 because we know that it will be completed on day 7. It will have a duration of 4 days. It means that the latest date possible to start activity B will be the 3rd day of project implementation. And we do exactly the same analysis for all the activities. So linear sequence, left to right, regressive sequence, late start and late finish dates, right to left. Activity age, we know already from the previous exercise that it will be completed on day 19. It will have a duration of 3 days, so it means it can start on day 16. 16 goes to G and goes to F. G will have a duration of 4 days. 16 minus 4 gives us 12, and 12 goes for D and E. E will be completed on day 12, that is the latest date. It will have a duration of 1 day, so it means that the late start date is 11. F will be completed on day 16, that comes from age. It will have a duration of 2 days. It means that the latest date to start activity F, it will be the day 14 of project implementation. But now we arrive at activity C, and activity C has 2 predecessors, E and F. Once you are doing the regressive sequence, you are trying to find the late start and late finish date. So whenever there are 2 predecessors activity, like C has E and F, we do exactly the opposite that we have done on the linear sequence. We use the earliest date possible. So it means that activity C, the earliest date possible to be completed is day 11. 11 and 14. So activity C goes here, the lowest value, 11, minus 2, 9. And then on A, we have exactly the same situation because B will start on day 3 and C on day 9. We always use, when we are doing the regressive sequence, we are always using the earliest date possible to complete activity A. So the earliest date possible to complete activity A is day 3. Because it's when activity B will actually start. And we have established now the regressive sequence. We know the late start and late finish dates. Next stop. We will identify the free float. What do we mean by free float? We will see the difference between early start and early finish and late start and late finish dates, and see the differences between them. We see here age, late start, late finish, 19 minus 19, 16 minus 16 gives us 0. Same thing on G, the same thing on D, the same thing on B, the same thing on A. But C, for instance, there is a difference of 6 days. 11 minus 5 gives us 6, 9 minus 3 gives us 6. The same thing for E, 12 minus 6, 11 minus 5, 6, and the same thing for F. What does this mean? It means that I can delay activity C up to 6 days without compromising the delivery of my project on day 19. I can delay the implementation of activity F to a maximum of 9 days without compromising the delivery of my project within the agreed time of 19 days. But if I delay activity B by one single day, I will compromise the completion of my project on 19 days. What the critical path method gives us is the possibility during the project implementation to actually take decisions on how to prioritize activities. For instance, activity B and C, they will both start on day 3. But we know that activity B has a free float of 0, which means that if I delay activity B, I compromise the completion of my project in 90 days. Activity C, we have here a buffer of 6 days. So it means that on day 3, I should prioritize the implementation of activity B because activity B cannot be delayed. Activity C, we have a buffer here that allows me to complete this activity with at least a delay of 6 days. So the critical path method, here it's A, B, D, G, and H, which is the sequence of activities with a free float of 0. This sequence of activities cannot be delayed, otherwise the completion of the project in 90 days will be delayed. Activity C and E, we have a buffer of 6 days, and activity F, it will have a buffer of 9 days. So it means that during implementation, during the management of our project, we know exactly what are the activities that are a priority that cannot be delayed and which are the ones that have a maximum delay without compromising the completion of the project on the defined time.